All right, we're doing college algebra, solving systems of inequalities, lesson 5.6. Lesson 5.6. Now we're just going to look at the computer here. So let me get the camera over here on the computer. We're going to start with problem number 2. Okay. Now if we notice our inequality right here, 5x, I'll zoom in a little bit. 5x plus 4y is greater than or equal to 20. Now, what I'm going to do is I'm just going to let y be 0, which makes this just disappear. That means x would have to be 4. Okay? So if y is 0, x is 4. Now, if I let x be 0, that would go away. And that means y would be 5. So let's zoom out here now. Okay? So he's over here on the graph. I'm going to click the graph, and I'm going to select the line because this is linear. Okay, and again, if I let y be 0, x would have to be 4. So I'm going to go right here, 4, 0. Now, if I let x be 0, y would be 5. So we were looking at right here. There's my line. Okay, now right here, notice the equal to bar, which means it's a solid line. You got to pay attention to that. If it's not, I would click this down here. See there, that makes it dotted, but it's solid, so I'm going to click it solid. Now I got a shade because this is an inequality. All right, that means one side of this line is shaded and one side is not. Now how do we determine that? Well, I got to try a test point, and the easiest test point is 0, 0. So I'm going to put 0 in for x and 0 for y, which means I'll have 0 plus 0. Is that greater than 20? No. It's not. 0 is not greater than 20. So that means my test point fails, which means this side is not shaded. It's this side over here. So I'm just clicking the little paint thing here, shade this side right here, and there you go. Okay. All right, what about, let's do this one. Okay. Try a new one here. All right, there we go. So on this one, now I've got a system now. I've got 2 lines. Now here's the thing. When you draw these 2 lines, you'll have 4 things. We'll go ahead and graph them. All right, so on this one, if I let y be 0, that means x is 0. So let's go ahead and click my graph here, 0, 0. Now if I let x be 0, well, y is 0, so that's the same point. So I'm going to have to do something different now to get me a second point. So what I'll do is I'll just let x be 1. If x is 1, 1 plus what would be 0? Well, that means y would have to be -1. So 1, -1. So I'm going to go 1, -1, and then bam, there you go. There's my other point. Now this line is solid. See, it's got the equal to line, so it is solid, not dotted. But now I got to see which side is shaded. Well, this time my test point, I can't use 0, 0 because it's on the line. So I'm going to have to pick some other point. So I'm going to come right here. Let's do 1, 0. 1, 0. So 1 for x plus 0 for y would be 1. Is that greater than 0? Yes, it is. So my test point works. So this side is shaded. So we'll shade it like that. Okay. Now, the other line. All right, well, if I let y be 0 on this one, x would have to be 1. So let's draw another line here. And if y is 0, x is 1. Okay, now if I let x be 0, well, what would y have to be? Well, it'd have to be -1. All right, so that means it'd be right there. There's that line. All right, now it's got the equal to bar, so it's also solid. It's not dotted. But now which side is shaded for it? All right. My shading disappeared. Let's move it up. It was on that side, so it's now this is what I started to say a while ago. When you have 2 lines intersect, you have 1, 2, 3, 4 regions. Only one of these regions will be shaded. Now I don't know if it's that one or this one. Let me go ahead and shade this one here because that's what was shaded originally for the first line. And then one of those I have to take off. That's what happens though when you graph that line. It clicks one of them off, but that time it clicked both of them off. I don't know why. Anyway, So now I got to try a test point for this one. Well, for this line I just did, I can try 0, 0 for this line because that's not on the line, on that line, the second line. So if I put 0 in for x, 0 for y, I get 0. Is that greater than 1? No, it's not. So this side of that line right there cannot be shaded, which means this shading right here, I'm going to have to take it off. And there you go. That should be my answer. All right, good deal. All right, let's do 4 here. Okay. Okay, well, I've got something wrong here. Let's go 4 again. Let's try it again. All right, there we go. Let's do a new one here. All right, on this one. All right, so if I let y be 0, that means x has to be 7. All right, and these are linear, so let's click a graph. There's my line. And if y is 0, x is 7, so there's that point. All right, if I let x be 0, well, I'm going to have a fraction. So I can't do that for the y variable on this one. So what I'm going to have to do is, since y has this coefficient, I'm going to put a value in for y. Well, I'm just going to put 1 in. Okay, well, let me put -1 in because I think it's going to make it go off the graph. If I put -1 in, -4 times -1 would be +4. All right, so I have x plus 4 equals 7. So I have to minus 4, which means x would have to be 3. So 3 and -1. So let's go to 3, -1 right there, and there you go. Now what I can do is 4 divided by -7 is -1.4 something, which 7 divided, no, it'd be 1.8 or something, and negative 1.8, and it looks like it's 0, so it's like -1.8. So I think this looks right. Only thing though, look here, it does not have the equal to line on it, so this is dotted. So I still have these highlighted. I'm going to click the dotted line. Well, there we go. There we go. So now we're dotted, so we're good on that one. Okay, now the other line. All right, if I let y be 0, 7 divided by 4, we got the same issue on this equation we had for the y variable up here. So I'm going to have to put a number in for x, which I'm going to put 1 in for x. 4 times 1 would be 4. 4 plus what is 7? Well, that means y would have to be 3. So 1, 3. So I click my graph. It's a line. So it looks like 1, 3 right there. Okay. Now, if I let x be 0, well, then y would have to be 7. So that works out good there. So right there. And so there's this line, but now it does not have the equal to line on it. You got to pay attention to that. So while I have these highlighted, I'm going to hit the well, I thought I had it highlighted good enough. I guess not. There we go, finally. There we go. So there's my 2 lines. Now the shading. Now I didn't shade the first line or the second line this time, but on this first line, I got to do a test point. And notice now 0, 0 is good for both lines because neither line goes through 0, 0. So if I put 0, 0 in here, 0 minus 4 times 0, which is 0, is that less than 7? Well, it sure is. So the first line we did, which was this one here, I'm shaded on this side of it. So I'm going to click my paint thing. I'm going to click here and here because both of these are on the top side of that line, the first line we drew. Okay, now on this second line we drew. Okay, 0 plus 0 is 0. Is that greater than 7? No. So my test point fails for that line, which means this side cannot be shaded. So I'm going to highlight it and delete it off. And there you go. It should be good. All right, good job. All right, we're going to go down to number 7. All right, we're going to have something like this here. And look, notice we got this is a line, but now this is x squared, which means that's a parabola. All right, so if I graph the line, all right, let y be 0. That means x has to be 4. So let's go 4, 0 here. And then if I let x be 0, 4 divided by 2, 4 divided by 2 would be 2. So if x is 0, y would have to be 2. Right there. All right, this is a solid line because it's got the equal to, so we're good right here. Now, what is shaded on it? All right, so I can try my 0, 0 for my test point. 0, 0 is my test point for the line. 0 plus 2 times 0 is 0. Is that less than 4? Well, it sure is. So I'm shaded below that line right there. Okay. Now, right here we got a parabola this time. All right, so this is x squared. Now look, this minus 2 is going to make it go down 2. So now on this one, we got to fully graph it ourselves. So here's the parabola. All right. And look at this. I think it'll be all right. I'm going to go down 2. So right here is where it's going to hit the vertex, right there. All right, now noticing from my x squared, there's no number, which means it has no stretch. So when I go over 1, I'll have to go up 1. And when I go to the left 1, I'll go up 1. All right, there's my parabola. Now notice how it took all this shading off down here. Now let's put this shading back. All right. Now for the parabola, is it shaded inside, which means I'll have just this and I'll delete this off? Or is it shaded outside of it, which means I'll keep this and I'll delete that part? Okay, so you're going to have to try a test point, which I can do 0, 0 on this because it does not go through 0, 0. So if I put 0 for y, I put 0 for x, I'll have 0 is greater than -2. Is that true? Most certainly. So that means inside my parabola, this test point is true, which means this shaded part right here, I need to delete it off. And that should be it right there. Now make sure I got a solid line, so I'm good on that. If I didn't have a solid line under there, it has to be dotted. So I would do this, but I think I'm good. All right, good deal. All right, we're going to do one more of these, number 8. Okay. Number 8, we have 2 parabolas. All right, both of them have solid lines there, so we'll just get that out of the way. We're not going to have dotted lines on this because they have equal to lines there. On this top one, it's a parabola. So let's click the graph. It's a parabola. And notice here we got x plus 8 in parentheses. This is horizontal, which is going to move it to the left 8. So that means my vertex is going to be on -8. And then when I go over 1, I'll go up 1. Go back. When I go to the left 1, I go up 1. So there's my parabola. Okay. Now it had no stretch. See, it has no multiplier for the x. So when I go over 1, I go up 1. Because 1 squared is 1. All right, now, do I shade inside the parabola or do I shade outside of it? So I'm going to try my test point, which is way over here, 0, 0. If I put 0 in for y, put 0 in for x, I get 0 is less than 0 plus 8, which is 8 squared, which is 64. Is 0 less than 64? Well, it sure is. So this test point is true. So I'm going to shade out here. Okay? So there's what I have for that graph. All right, now down here on this one. All right, now look, this is just -3x squared. This right here, the negative is going to make it go down. And 3 is a stretch of 3. When I go over 1, I'll go down 3. But it has no shift. So it means the vertex is right on the origin. So let's click this. My vertex is right on the origin here. And when I go over 1, I'll go down 1, 2, 3. All right, when I go back this way 1, I go down 1, 2, 3. And there's, now notice how it took the shading out, but we got to check, make sure that's right. Is it shaded inside the parabola or is it shaded outside like it shows? So let's just figure this out here. And I can't try 0, 0 this time because the parabola goes through 0, 0. Okay. All right, so what I'll do is I'll just do, I'll do 1, 0, which is right here. All right, 1, 0. So if I put 1 in for x, put 0 for y, -3 times 1 squared would be -3. Is 0 greater than -3? Well, most certainly it is. So this test point right here is true, which it's stated. So that should be my answer right there. Good deal. All right. Now, we're going to skip to number 10. So I'm going to go back to my paper down here, and we'll work this out on the paper. Okay, now what we have here on number 10 is this is our feasible region, which this feasible region comes from constraints that are given, and we'll talk about this more in another problem that might make more sense. But anyway, this is my feasible region. So x can be anything in this region or on the edge of this region. So what I have is I've got this objective function right here. Okay? And I want to maximize, I want to find the minimum and the maximum values of the objective function. So basically what I'm going to do is I'm going to take these corner points of the feasible region, and I'm going to put these values in for x and y in this objective function. All right, so if I put 3 in for x and put 0 in for x, 7 times 3 is 21, 4 times 0 is 0, so 21 plus 0 is 21. So I get a 21 when I do that one. So I'm just going to write it there on it. All right, what about 8, 5? What do I get when I put that in? So put 8 for x, put 5 for y. 7 times 8 is 56. 4 times 5 is 20. When I add those, I get 76. All right, there's what I get there. Same thing here, 8, 9. I put 8 for x, put 9 for y. 7 times 8 would be 72. 4 times 9 is 36. Add these together, get 108. And now 3 tens the last one. 3 for x, put 10 for y. 7 times 3 is 21. 10 times 4 would be 40. When I add that, I get 61. Okay. So now I'm ready to answer the question. The maximum value of the objective function is, well, let's see here. It looks like 108, isn't it? 108 at point 89. Okay. Now the minimum value, all right, the minimum value is 21, isn't it? Yeah, 21 is the lowest. So the minimum value is 21, and it occurs at 0.30. So there you go. There's my answer for that. Okay. So now number 11 is a similar type problem. You should be able to try doing this. So there's your feasible region. The objective function is right here. And so you're just going to put those values in and find the maximum value and the minimum value. Okay? But we're going to go down to number 12. Okay? Number 12 right here. And I'm going to fold this over. All right. Here's number 12. All right. Now, what this says here is an agency wants to ship food and clothing to hurricane victims in Louisiana. Commercial carriers have volunteered to transport the packages, provided they fit the available cargo space. Each 20 cubic foot box of food weighs 40 pounds, and each 30 cubic foot box of clothing weighs 10 pounds. The total weight cannot exceed 16,000 pounds, and the total volume must be at most 18,000 cubic feet. Each carton of food will feed 11 people, while each carton of clothing will help 6 people. Okay. All right. So here's what this means. We're shipping this food to the Louisiana, which means we're limited to how much space we have in this vehicle, and we're also limited to how much weight we could put in the vehicle. So if you break this down, we're sending food and we're sending clothing. All right, so if I write this down, I got food, I got clothing. All right. All right, this is each 20 cubic foot, so this is 20 cubic foot box of food weighs 40 pounds. And each 30 cubic foot of clothing weighs 10 pounds. All right. But here's what it says. The total weight cannot exceed 16,000 pounds, and the total volume must be at most 18,000 pounds, which means we got to be under these numbers right here with our weight and our space. So that gives me constraints. Okay, that means if I'll just do F and C for my variables. All right, so looking at my weight, 40 times each box of food plus 10 times each box of clothing has to be less than or equal to 16,000. Okay, and then as far as my space, 18,000, my volume, that means 20 times my F plus 30 times my C has to be less than or equal to 18,000. And these are my constraints. I have to be under these numbers right there, whatever F and C are. Okay. Now, side note is right here. Each carton of food will feed 11 people. Each carton of clothing will help 6 people. So that gives me my objective over here. Z is what I'm going to be help the number of people I'm helping, and that's going to equal 11 times however many boxes of food I send plus 6 times however many boxes of clothes I send. And this is the ultimate thing here, my objective function. Okay, and I want to maximize this. All right, so let's just move this up some. Okay. So I need to graph these constraints. So let me move this up a little bit. And let's do this, okay? I'm going to graph these constraints. All right, so here's my graph. Okay, this graph don't have to be perfect. But if I graph this one, I'm going to do the same thing. If C was 0, then I do 16,000 divided by 40, which would be 400. Okay, so it means here's F down here, here's C over there. Okay, so I'm going to just do 400 right here. It hits right there. And if I let F be 0, okay, let F be 0, that means 16,000 divided by 10 would be 1,600. So I'm going to put that right here, 1,600, and there's a line that goes like right here. Now, if I try 0, 0, 0 plus 0 is less than 16,000. This is what's shaded. Okay, now I do this one. Same thing. If C is 0, 18,000 divided by 20 would be 900. So this would be 900 right here. And then 18,000 divided by 30 would be 600, which is right there. Okay, and so I draw this line right there. And 0 plus 0 is less than 18,000, so it's got to be shaded below it, which means I have this shaded region right here. This is my constraint region. So I know this point right here is 0, 600. This point right here is 400, 0. This point is 0, 0. This point right here, I don't know. I have to solve the system. Well, I've already done that previously. That's 300, 400. And now these are my constraint region. I just try these points in here. So there's my objective function. Okay, so if I put 0, 600, 0, 600, that's 3,600. If I put 0, 0 in, 0, 0, that's just 0. If I put 400, 0 in, 11 times 400 plus 6 times 0, that's going to be 4,400. If I put this in, 11 times 300 is 3,300. 6 times 400 is 2,400. Add those, that's 5,700. Now, how am I going to help the most people? Right there. That's how I'm going to help the most people. If I send 300 boxes of food and 400 boxes of clothing, I'll maximize my space on the truck that we send it in, and I'll help the most people possible. So that would be my answer. All right, so that's what this says right here. How many cartons of food and clothing should be sent to maximize the number of people assisted? I need 300 cartons of food, 400 cartons of clothing, and the maximum number assisted would be 5,700 people. And there you go. That's how you do it. So now if you have any questions, just let me know and I'll help you any way I can. See ya.